Hello guys, this is Berker, and this is the development video for the Prim's algorithm in C++. Alright, so this is my test input, this is my graph, this is the data that actually describes my graph. Alright, 6 is the number of nodes, 8 is the number of edges, and this is the description of the edges. Alright, and this is my input file, prim.in, and this is my graph as designed in Paint. Alright, so let's go to the code. Alright, this is my code. Okay, it compiles. Alright, let's see how much time it needs. Alright, it needed 6 seconds. Alright, let's make it again. Alright, so it compiles with no bugs, and these are the this is the analyze. I'm gonna analyze the algorithm line by line. So I include my 3 libraries. This is for reading from the file, this is to output on the screen, this is the queue for the priority queue I'm gonna use to make the algorithm faster. This is using namespace std, and in this command I just say that I'm gonna read with fin from prim.in file. Alright, this is the priority queue. I'm declaring the priority queue. I use this line right here to say that my priority queue will have the minimum value on top and not the maximum as it is by default. This is my 2 variables, n and m, and for nodes, m for edges. This is the sample vector I'm going to use to construct the adjacency list right here. Alright, so this is the adjacency list. It has pairs inside of it. Each pair will have the weight and the destination of the edge. Alright, same as it is in the priority queue. Alright, now here I have the visited array. I name it v's. In the beginning it is all zeros. I have said that the maximum number of edges, sorry, the maximum number of nodes for these source code to run is 1000. You can change this one, it's no big deal. Alright, it depends on the memory of your computer as how far it can go. And so I have now declared the array as I said, and this is the MSTW, which is the weight of my minimum spanning tree. I want to output the weight. Alright, so this is the main function. I'm reading n and m. I'm setting z as equal to m, and I declare these 3 variables a, b, and w. Alright, a is the first node, b is the second one, and the weight is the weight that the edge has to connect these 2 nodes. Alright, so until z is going down, I'm reading a, b, and w, and with these 2 lines I push the data into the adjacency list. I say that adjacency list of a, I'm gonna push the edge w with weight w, which connects a to b, same as doing here. I say that in the adjacency list of b, I'm pushing back the edge which has the weight w and connects b with a. Alright, so this is the loading phase. Okay, I load the edges, and now I'm gonna do the prim algorithm. So I'm gonna pick a node. You can change the number here, you can put any node you want, and the node you're gonna choose is gonna be written here in the C node. Right, so I declare C node as the current node, and vsn is the variable I'm using to count how many nodes I have visited. Alright, so I'm gonna run the Prim's algorithm until visited n is smaller than n minus 1. Alright, so this goes for I'm gonna get in this loop for 0 to n minus 2, and that would give me n minus 1 times I visit this loop. I do not need more than n minus 1 because the last node will do nothing. Right, I don't need to do anything from the moment I'm gonna have the last node. Alright, so I mark the node here as visited, the current node as visited, and I increase the visited nodes variable. Alright, now I push all the edges that are in the adjacency list of the current node inside my priority queue with this loop right here. Alright, then I pop all the edges that are on the top and they create a cycle. Right, so until this edge, the top edge in my priority queue, is going to a visited node, which means it creates a cycle, I pop it. Alright, so now after going out of this loop, I'm sure that the top edge I have is not gonna make a cycle. So there we go. I add the weight of this edge into my MSTW, which counts the weight, and I set as current node the node that this edge visits, and then I pop my edge, and I do this for n-1 times. Alright, and then I output my minimum spanning tree weight is, and the minimum spanning tree weight is output. Sorry. Yeah. So let's run this program, and the MST weight is 5. So let's check this out. So here's my graph, and I have done this by hand. You can do this by hand and see that the MST is this when you start from node A. Alright, and so the MST weight is 1 plus 3 plus 1 minus 2 plus 2 minus 2. This is the sum of all the weights of my edges, and it actually gives me 5. Alright, so that means my source code right here works pretty well, guys. I'm gonna have a link which will lead to the source code, and you can copy the source code and use it anyway. So that's pretty much it, guys. I hope you will understand the algorithm. If you want me to make a tutorial video for priority queues or for anything else that you don't understand in this code, just comment in this comment section below and I'm gonna make a video, guys. So please subscribe if you liked it, and I will see you in the next one. Goodbye.